So now I'm going to do a couple of 3 resistor circuits, and we'll see how far I get. I'm probably going to need several videos to go through these because they're going to be a little bit more involved, and I'm probably going to do like some kind of granddaddy circuit at the end to just sort of show you how you can scale this up. So what I'm going to do is I'm going to have a 3-volt battery, and it's going to go into, first it's going to go into my 1.5 kilo ohm resistor, and then it's going to go into a parallel right like this, and so this is going to be my 2.2 kilo ohm, and this is going to be my 4.7 kilo ohm. Okay, now what I'm going to have to do to find R total is I'm going to have to break this into I'm going to have to break it into resistor pairs. Now this is my parallel pair from the previous circuit, and so I can kind of draw a bubble around this where there's one wire coming into the bubble and there's one wire coming out of the bubble. So I'm going to have 1 over R total is equal to 1 over 2.2 kilo ohms plus 1 over 4.7 kilo ohms. And now from my previous video I've got that result. If I do that out, I'm going to end up with R total is equal to 1.5 kilo ohms. Now, conveniently enough, I've got that, so let's call that RA. So I can think about these 2 resistors as a single resistor with a value of 1.5 kilo ohms. Now I'm going to add that in series. I'm going to say this is R1, R2, R3. So I'm going to say R1 plus RA. Our total is going to be R1 plus RA is going to be 1.5 kilo ohms plus 1.5 kilo ohms. So my R total is going to be 3 kilo ohms. Well, now that makes actually my life really simple. There's a lot of things I don't have to be grabbing for the calculator. Now I know that I is V divided by R, so I've got 3 volts divided by 3 kilo ohms. I'm going to end up with 1 milliamp. So my current is going to be 1 milliamp. Now let's do a little detective work. Let's go R1, V1, I1, R2, V2, I2, R3, V3, I3. And I've got my values for my resistors: 1.5 kilo ohms, 2.2 kilo ohms, 4.7 kilo ohms. Now, what I said in an earlier video from Kirchhoff's law says that if 1 milliamp is leaving this battery, 1 milliamp has to come back to this battery. Well, if 1 milliamp leaves, then 1 milliamp has to go through this resistor. So I know what the current is through R1. I know it's got to be 1 milliamp. Now, if I use V equals IR, well, this is really simple. V equals IR, 1 milliamp times 1.5 kilo ohms. That's going to be 1.5 volts. Okay, I swear I just grabbed random resistors, and it's just kind of working out right. The next videos are not going to work out nearly so nicely. Okay, and so it started off with 3 volts. Now this resistor ate up 1.5 volts out of the 3. Now we remember from a previous video that the voltage drop in a parallel circuit, which is what I have inside my bubble, has got to be the same for both resistors. So if we started with 3, we ate up 1.5, there's got to be 1.5 left. So there's 1.5 volts left in each one of those resistors. Okay, now we got to use I equals V over R. So I'm sort of going fast because we've already sort of done the development of the thought. I'm going to get 0.68 milliamps. And this is going to be 1 milliamp minus 0.68. I should get 0.32 milliamps. But just to try it out, just to make sure, we're going to have 1.5 divided by 4.7 E3. And I get, I didn't do the E3. E3, then I get 0.32 milliamps. Okay, so let's go through this really quickly. Kind of smoking quick. Okay, I have my circuit already sort of built, more or less. And we're going to just fly. We're going to be on volts. Well, first off, let's do ohms because that's where we are. We're expecting a total of 3 kilo ohms. And so if I go to this here, I go boom, and I get 2.95. Good. My parallel circuit is that 1.5 that I expected. And so everything is working out in terms of my total resistance. Here I've got, if I go to volts, this should be 3 volts. And it is. This should be 1.5 volts. And it is. And then over on this one, I kind of mangled those together. This resistor all on its own should have 1.5 volts, and it does. And this resistor here should have 1.5 volts, and it does. Now my total current should be 1 milliamp, so we should be able to go right here. And so if I disconnect here, I should get 1 milliamp, and I get 0.992. Now, if I look at how much is going, and so that's going to be, that's what's going through this resistor. I'm not going to take the time to do it. If I'm going to pull this one out, that one was my 4.7. So from my 4.7, I'm expecting 0.32. And I get 0.319. 0.32. Perfect. And then on this one, last but not least, I'm going to pull out my 2.2, measure the current in there. It should be 0.68 is my prediction. And I get 0.679. So I'm all happy with my simple resistor circuit. It's amazing how this stuff works like it should. Okay, another one of these in the next video.